Hello, welcome to Learning Samba Quickly, a course overview. This course is designed with a mission to get a Samba server up and running with minimal effort spent in learning. These days, I'm increasingly noticing that there are no regular IT folks, particularly in small companies, and that a regular non-IT employee is given the task of a system administrator. While it is unfair, it makes sense for your boss from the business perspective. This course is also for you. You are the modern-day warrior. Some prerequisites. You must have some knowledge of any Linux operating system, Windows and networking. You need Windows 10, Oracle VM with CentOS and Ubuntu. You're also provided free 2 books written by me, Learning Basic Linux on Windows 10 Machine, and Samba, a quick guide. Happy learning! Welcome to Learning Samba Quickly. This is a section where we learn the basic definition of Samba. What is Samba? Heterogeneous networks are common these days. The days of single monolith systems are long past us. In a typical support center, you are given a Windows 10 laptop, though even Windows 7 is still common, and a VNC connection to a Linux virtual machine somewhere on a farm, whether on premises or outside. The support person will send email, serve internet, do desktop sharing with her customers, and do experimentation or simulate the customer's issues on a Linux box. This is a typical scenario these days in corporate environment, where the norm is to minimize the hardware given to the employees. It is important for you as system administrator or IT in charge to provide your user access to both the operating systems, Linux and Windows, and Samba offers a fine way for the user to share resources between the two. Simply put, you have users using both Linux and Windows systems in your organization and need to transfer files and share resources with each other. Then, Samba is an easy way to accomplish this task. In most organizations, all you need to do is provide access to the home directory of your Linux users to transfer files to or from Windows. While you can delve deeper, but this one primary task is what we learn in this course. For instance, many software exist in Linux due to faster response time. But the same users will have mail access from Outlook, and they really need to transfer files from Windows to Linux or download software from centralized location on a Linux box, which is a common activity. Thank you. In this demo, you learn how to install the Samba packages on the Ubuntu system. Let us do some prep steps and document the information of the resources we are working on. This is important work. And as IT folks, we have to document each and every step. First, let us check the version of Ubuntu we are on by checking the file issue in the etc directory. Let us go to the etc directory and cat the file issue. So the Ubuntu version we are on is 16.04. Now let's take the IP address of the Ubuntu system using the command IP space A. Clear the screen. IP A. And this is the interface we are on, and this is the IP address 192.168.1.13. Time to open the Windows client system. The main objective of this section is to allow the Windows users to access their directories on the Ubuntu system. We have opened the Windows command prompt. Now enter the command ipconfig all. ipconfig/all. The IP address of the Windows system is 192.168.1.4. Clear the screen. Let us check the ping connectivity between Windows and the Ubuntu system. So we ping the Ubuntu server from Windows 192.168.13. Okay, it is successful. So we know that the connectivity between Windows and the Ubuntu system is fine. Let us go back to the Ubuntu server and install the Samba packages. We're back on the Ubuntu server. Let us install the Samba packages using the sudo command sudo apt-get install Samba. There is no root user in Ubuntu. You must always use sudo to get the privileges you want to install the software. So press enter, the password of course, 25.8 MB of additional space will be used. Let us go ahead. So we have completed the installation of Samba. Let us see if the directory Samba has been created inside the etc directory. We are in etc directory, Samba. Okay, so we know that the Samba installation has been successful. Hi folks, in this demo we learn about configuring the Smb.conf file on the Ubuntu server. The Smb.conf file is created when you install the Samba packages on Ubuntu. It is the configuration file that controls the behavior of the Samba daemon. We are going to modify the Smb.conf file so that Windows users can see their directories on the Ubuntu server, or actually from the Ubuntu server. The location of the file is etc Samba. We are on the etc Samba directory. Let us check the content. ls-l, and we see 2 files and 1 directory, and the file we need is smb.conf file. Since this is a system area, we need sudo to modify this file. Sudo nano smb.conf. Here we have opened the file. Now we have to go to the global section of smb.conf file, and we need to enable sharing of the home directory in the smb.conf file in the home sections of share definition. So let us go. Okay, so we are in the share definitions and we have to uncomment this lines. Let us uncomment this line. Browsable. Let us make the browsable yes. Read only. Okay, fine. Let us uncomment this as well and save the file. Yes. Okay, we have saved the file. In this way, you can access your home directories on Ubuntu from Windows without logging into Ubuntu. Now let us start the service. Sudo service smdb. This is the it is SMBD. This is the daemon. D stands for daemon. Start. Okay, I think it has started. The last step in this demo will be to add an existing user on Ubuntu to the Samba database. And the existing user is Sujata. Who am I? I'm Sujata. So let us add this user to the Samba database. Sudo smb password -a Sujata. So just give any password. You have to remember this password because you need it on Windows. Okay, so we have added the user Sujata to the Samba database. So when you try to access Ubuntu's home directory from Windows, this is the user I'm going to log in, and you have to use this passport which we have just given. So thank you. Hello, in this demo we will learn to access the home directory of Sujata from the Windows machine, and we are on the file explorer of Windows 10. We have to put the IP address of the Ubuntu server, which is 192.168.1.13. Let us try it. Okay, I directly get the directories of the Ubuntu server, Sujata and home. Let me try and map the directories. Map network drive. Try another Y and connect using different credentials. So I'll get the credential box. This is the box that you should see in the beginning. So I'll put the password. Okay. And for the Windows user, it is just like another drive. Okay, thank you. Welcome to the section Ubuntu Samba installation with Windows Client Access. In this section, you will learn about the following topics: scenarios where Samba is used, installation of Samba on the Ubuntu platform, steps to ensure connectivity between Windows and Ubuntu, introduction to Smb.conf configuration file, using the testparm command on Ubuntu, starting Samba daemon on Ubuntu, accessing Ubuntu file system from Windows. If you need to provide a centralized location for your Windows users to keep their data in or just access their home directories on Linux, this solution works perfectly. Ubuntu is ideal because the Samba installation and configuration process is much simpler here. To the Windows users, everything appears seamless. The drive that you share on Ubuntu appears just like any other drive on your Windows 10 file manager. If you keep your users' data in an Ubuntu machine, which your Windows users access using Samba, then taking backups from Ubuntu and from a centralized location is much easier. Another scenario could be centralization of software deployment. You can download images of software that you need and keep it safely on the shared Ubuntu Samba location. Your Windows users will just go to that location and follow the instruction. You should provide a doc file to your users on how to access and install the software. Your software has fewer chances of getting infected on an Ubuntu server. Samba was developed to provide file and printing services across Windows-based systems. However, it is implemented on other operating systems as well. Ubuntu, CentOS, and Kali Linux support Samba. The core component of Samba is Server Message Block or SMB. What is SMB? This is a protocol stack that defines rules, procedures, basically commands, that two nodes follow or adhere to transfer files or use resources such as printers. Samba provides integration between Windows and Linux and even Linux to Linux. There are currently two versions of Samba in use, Samba 3 and Samba 4. Samba 3 is more stable, while Samba 4 supports Windows Active Directory. Installation of Samba on Ubuntu. Let us get started by installing Samba on Ubuntu. The command is sudo apt-get install Samba. Note, there are no root user in Ubuntu. You should always use sudo to get the privileges you want to install the software. Now that you have installed the Samba software on Ubuntu, let's check the connectivity between Windows 10 and Ubuntu. Because if there is a bad network connection between two nodes, the whole exercise becomes futile. Identifying IP address from a Windows machine. To get the IP address of a Windows machine, open a command prompt. By hovering your mouse on the Windows button and mouse right clicking, select Run and type CMD and enter the following command, ipconfig/all. Look for the section called Ethernet adapter. This is the section which provides IP address and the physical address of your network card. The physical address is a unique number burned into the memory of your network card. The IP address as per the command is 192.168.1.3. Here it is. This is the IP version 4 format. Identifying IP address from an Ubuntu machine. On Ubuntu, use the command IP space A. The IP address of the Ubuntu machine is 192.168.1.3. You can see it over here. The ping test. From the Windows machine, open the command prompt and run the ping command to the Ubuntu system whose IP address is 192.168.1.13. It is successful, and that tells us that connectivity exists between the Windows and the Ubuntu system. Now that we have established that connectivity exists between Windows and Ubuntu server, let us go back to configuration of Samba server. The Samba configuration file Smb.conf is in the etc Samba directory. The etc directory is where all configuration files of Linux services reside. The configuration file dictates how the daemon, in this case Samba, behaves. A daemon is a process that runs in the background. So let us go over to etc Samba directory and we see two files and one directory, and the main file is what we are looking for is smb.conf. We continue with smb.conf file on the Ubuntu system. The purpose of this exercise is to give the Windows users access to their home directories on Ubuntu. The Smb.conf file has several settings or sections with which minimal configuration can be achieved. Let's make few changes in the file. Open the file using Nano, an editor like Windows Notepad if you are not well versed with Vim. Step 1. Go to the global section of Smb.conf file, which is the first setting that is globally applied. Step 2. Enabling sharing of the home directory in the smb.conf file in the home section of shared definitions. Just look at the setting. They are all with the comment here, semicolon. You should merely uncomment the fields. This enables sharing of the home directory of the user we are logged in as. So I have removed the semicolons from here. There is another change that you must make. The setting is also part of the home section. The shared directory homes should not have the default setting. Change from read only is equal to no to read only is equal to yes. This is all you need for a default operation of Samba share on Ubuntu. Starting Samba service on Ubuntu. Now let us start the service. Sudo service smbd start. Now that you have started the service, it is time to create users. Since Windows and Linux have different authentication schemes, we should create Samba user credentials for your users. Your regular Windows users will not be able to use the Samba shares unless you integrate your authentication using Active Directory. Creating Samba users using the following command: sudo smb password -a Shujata. Note, the user Shujata already exists as a legitimate user on Ubuntu. The testparm command. Test if the Samba configuration is fine using the testparm command. The testparm command checks the integrity of the configuration file smb.conf file. And we can see that everything seems to be okay here. Particularly, just look at the home section. This is where we made changes. Now, time to access the Ubuntu directories from Windows. Let us go over to Windows and try our luck. Open File Manager on Windows 10 and enter the IP address of the Ubuntu system in the following format: //192.168.1.13, which, as you know, is the IP address of the Ubuntu server. You will be asked credentials. Enter the Samba user credentials that we created using the Samba password command, not your regular Windows credentials. Here we go. We can see the Shujata directory from the Samba server. So we are still in Windows. Let's see what's inside the Shujata folder. As you can see, there are a lot of Linux stuff. You can see the .cache file, config file, desktop documents download, the bash_history file, bash_logout, etc. Checking if we are seeing the same directory from Windows. So let's go back to Ubuntu and check the directory that has been shared. Use the ls-al command. The -a option will show the hidden files on Ubuntu which are clearly visible from the Windows snapshot. As you can see, you have the same bash history file, bashrc, and all the other directories which could not come in the snapshot. Now, let us go back to Windows and map the Ubuntu drive on Windows. Just use the same procedure. So we have mapped the Ubuntu drive to the S drive. Then for your Windows user, it is just another drive. This is how easy it is. Thank you. Hello, in this demo you will learn about the command testparm. As per the definition on www.samba.org, this command checks an smb.conf configuration file for internal correction. You should mind two things while working with configuration files in the etc directory. Always take a backup of the original file, and in case you are modifying the smb.configuration file, do not forget to run the testparm command right after it. So let's go ahead and run it. testparm. Okay. It has processed the section that we had modified, the home section right here. Let us press enter. And this is the area which we modified and it looks fine. So we can end this demo. Thank you. Steps before installing the Samba software on the CentOS platform. Step 1. Get the IP address using the IPA command. You can also use the ifconfig command. ifconfig, pipe it to less. This is the interface we are looking for, ENP0S3, and the IP address is 192.168.1.12. Step 2. Get the hostname of the CentOS box using the hostname command. The hostname is shujata.localdomain. Step 3. Perform a ping test from Windows. Open a command prompt. Ping 192.168.1.12. Okay, it is successful. And we have determined that there exists network connectivity between the client, that is the Windows, and the CentOS server. Exit. Step 4. Install the Samba package on your CentOS machine using either the sudo command or login as root. Let us log in as root. Clear the screen. Yum install cifs -utils Samba client Samba common. The installation is taking place now. Yes, we have completed the installation. The Samba configuration file Smb.conf is still in the etc Samba directory. Let's check the contents of this directory. Clear the screen. cd etc Samba ls-l. We see the smb.conf file. So we have determined that we have installed Samba successfully on the CentOS platform. Thank you. Hello, to check if permissions are fine across the platforms, that is on Windows and CentOS, let us create a directory on storage directory from Windows and then check from CentOS whether it was created or not. So this is the way to verify if both the operating systems are in tune. So I am on Windows and I'm accessing the storage directory from CentOS. So let me, from the Windows side, create a directory inside storage. So let me create a folder. Hi from Windows. Fine, so it has got created. So let me go over to CentOS and see if this directory has been created or not. Where am I? I'm in Home Sujata. Let me go to the root directory. pwd, let me go to storage. Here it is. Let me do ls-l. And I see that this directory has been created. So the permissions are working perfectly fine. Thank you so much. Hello, in this demo we will start the Samba server with these new settings that we added in the previous demo. If you remember, we added a section called storage. Also, we will add users in the Samba database. Let us first start the Samba server. I am in the root system ctl start smb system ctl start nmb. Let us add a user into the Samba database. Let us add Shujata, smb password -a Shujata. Okay, so we have added the user Shujata. You don't get this message because I've already added it to test this demo. So now let us go over to Windows and try to access the CentOS Samba server using the IP address. Here goes, run Okay, it's already there. Let's click on OK. Oh wow, we get a network error. Windows cannot access 192.168.1.12, which is the IP address of the CentOS server running the Samba daemon. The reason is probably due to the firewall, which is not allowing access to the ports used by the Samba daemon on the CentOS server. For now, let us go over to the CentOS server and disable the firewall using the command systemctl stop firewall d. Okay, let's try and access from Windows again. As you can see, after we disable the firewall, we can access the directories that we created on the CentOS server and shared them, and we can see the same directories from Windows. Thank you. Hello and welcome to the new section, CentOS Samba installation with Windows Client Access. In this section, you learn about the following topics: steps before installing Samba software, identify the Samba packages for CentOS, exploring etc Samba directory and Smb.conf file, some notes about SE Linux, making changes in the Smb.conf file, using the testparm command, start the Samba service, accessing CentOS resources from Windows, and stopping the firewall for testing. Steps before installing the Samba software. Step 1. Identify the CentOS version and IP address. Document it away. The following CentOS machine has been used to create this course. To check the version, look at the file called redhat-release, which shows that we are using CentOS 7.4. On Windows system, PuTTY is used to generate an SSH session to the CentOS whose IP address is 192.168.1.10. Get the IP address on CentOS using the IP-A command. You can download PuTTY from this particular site, www.putty.org. It is basically a SSH telnet software to access Linux boxes. Step 2. Ping test. Ping from the Windows to the CentOS box, which is a must test. Ping 192.168.1.10. It is successful. We thus determine that we can communicate with the CentOS Samba server from the Windows 10 machine. Installation of Samba packages on CentOS. Log in as root or use sudo to install the packages samba-common, samba-client, Samba, and cifs-util as follows. The command is sudo yum install cifs-utils Samba, Samba-client, Samba-common. Installation of Samba package on CentOS, we continue. The Samba configuration file is as same as in Ubuntu and resides in the same directory, etc Samba. Let's check the content of this directory. So we see files called lmhost, smb.conf, smb.conf.example. As you can see, there is a file called lmhost in the etc Samba directory. The lmhost file provides local resolution between the host names and IP address in the local network. It is like the etc host file on Linux for local resolution. Consider lmhost and host files as telephone directories of the residents of your building as compared to the telephone directory of the whole city, like the domain naming system DNS. The NetBIOS protocol uses the lmhost file. This is a non-routable protocol, that is, it cannot go past a network router or a gateway. I was talking about the NetBIOS protocol. Disabling SE Linux. An important step on CentOS will be to disable SE Linux. Enable SE Linux has known to cause problems in Samba configuration. Do not even think of doing this on live production servers. You will get into a lot of trouble. This is because SE Linux adds a layer of unprecedented security policies on your system in line with your company's requirements. To check the status of SE Linux, use the command se status and we can see that it is SE Linux is enabled. The first line indeed indicates that SE Linux is enabled, and here are the steps to disable it. The configuration file of SE Linux is SE Linux, which resides in the etc sysconfig directory. You need to be root or use sudo to open and locate the keyword SE Linux in capitals in the file SE Linux, which looks like SE Linux in capitals is equal to enforcing. We are still with disabling SE Linux topic. Change the value to disabled. So from enforcing, we change it to disabled. So now it will be SE Linux is equal to disabled. Save the file and exit and reboot the system. Then you come back and check the status of SE Linux using the command SE status again. So now we get that SE Linux status is disabled. Back to Smb.conf file now. Instead of using the default home section, which is not writable, you can subscribe to a real-life scenario where your Windows-based users will store their files on CentOS hard disk. To achieve this aim, you can define a section in the Smb.conf file. However, first, let's create a directory on CentOS with all permission, which is then shared, while Windows-based users mount this directory on their Windows 10 system and get to store their files at this centralized location on CentOS. Creating a directory on CentOS to share. So we are in CentOS. The step 1 will be creating a directory called storage in the root. The command is sudo mkdir/storage. Step 2, give all permissions for the creator, members of the group, and the world. We do it by the command sudo chmod 777 storage. Storage is the name of the directory that we just created. Step 3, check the permission using ls-l, and we can see that it has all the permissions. Now open the smb.conf file in the directory etc samba and add the following section. So we are adding a section called storage. Comment added by admin to enable storage for Windows 10 users. Path is of course /storage. Writable, of course, it is yes. Step 4, save the smb.conf file. Step 5, check with testparm command to see if the changes in the smb.conf file are accurate. So we run the testparm command and we see that it has processed the section that we have added storage successfully. So the testparm command was fine. Let us start the Samba service using the following commands: sudo systemctl start smb, sudo systemctl start nmb. Step 7. Now you should create Samba users. To reiterate, you cannot use the operating system usernames. You must create Samba users. In the following example, a user called Bobby was already created in CentOS. Now it is added to the Samba database. The command will be sudo smb password -a Bobby. So it has added the user Bobby, as you can see from the message here. Accessing storage directory from Windows system. Now go to Windows 10's File Explorer and enter the IP address of the CentOS box. You should get the credentials windows, right? However, what you get is a network error. The culprit here is the firewall. You should stop the firewall on the CentOS machine and see what happens. The command to stop the firewall is sudo systemctl stop firewall d. Checking on Windows system. Now go back to Windows and check if you can access the shared directory on CentOS machine from the Windows File Explorer. Yes, you can. After you've entered the user's credentials, that is Bobby's credentials on the Windows side, you get to see the following screen. You see the directory Bobby, which is the home directory Bobby, and the storage directory. That's what we wanted. And in this directory, we are going to store files, right? The user's home directory has been shared by default along with the storage location. Check if you can create a folder inside the storage directory to check the permissions. Create a folder called test_folder inside the storage directory. So inside storage, we have created this directory called test folder. Let us go back to CentOS and check if indeed this folder has been created on the CentOS Samba server. As you can see, it has been created. So all the permissions are checking out. While we are on CentOS, you can use the Smb status command to check who is logged in. And you can see, you can run the command as sudo smb status, and you can see that the user Bobby has been registered. Thank you. Hello, in the last demo, we disabled SE Linux. In this demo, we will prepare the CentOS server by modifying the Smb.conf file. We will add certain keywords so that we can share a directory in the CentOS server which can be accessed by our Windows clients. Step 1, let us create a directory to share in the CentOS machine. mkdir/storage. Okay. So let us go to root and check if this directory is there. Okay, we have created the storage directory. Clear the screen. And let us give it all permissions. chmod storage. Sorry, chmod 777 storage. That's it. Now let us modify the smb.conf file, which, as you know, is in the etc samba directory. /etc samba. Clear the screen, open the smb.conf file, and let us add the keywords. So we are creating a section called storage. Comment added by admin to enable storage for Windows clients. Path is /storage. Writable, yes. So let us save the file. Yes. Let us run the testparm command to see if everything is okay with the smb.conf file. Testparm. Yeah, it is there. So it has process the section we have added storage. Enter. Yes, so it looks okay. Thank you. Hello, we are on the CentOS system where we just installed the Samba software. In this demo, you will learn to disable SE Linux so that Samba faces no issues. This is done so that we can learn the Samba concepts in our time. You should not disable SE Linux in your office network. This is only for academic purpose. Let us first begin by checking the status of SE Linux using the command se-status. Please note I am in the root prompt. We see that the SE Linux status is enabled. We have to disable it. To disable it, let us open the SE Linux file in the etc sysconfig directory and look for the parameter SE Linux in capitals and change its value to disabled. Clear the screen. Let us go to the directory etc sysconfig and open the file SE Linux. Okay, and you can see that SE Linux is right now set to enforcing. And you can see that enforcing means that SE Linux security policy is enforced, and we need to make this value to disabled so that no SE Linux policy is loaded. Let us change the value to disabled. and save the file. Okay, clear the screen. We have to reboot the system and then we will join the class again. Let us now check the value of the se status command after the restart. Okay, it is disabled. So we have successfully disabled SE Linux, and that completes our demo. Thank you. Hello, in this demo we learn about sharing directories across two Linux boxes. Since we've already done the prep work in other demos, let us just start by installing the Samba packages on the second CentOS machine called Bobby, which will be our client. Login as root. Let us install the Samba packages on the client. Yum install cifs -utils Samba client Samba common. We have completed the Samba installation on the client Bobby. Let us do one test though, the ping test. Clear the screen and ping from Bobby to the Samba server Sujata, whose IP address is 192.168.1.12. Ping from the client to the server Sujata is successful. Clear the screen again. So let us go over the server and check if the Samba server is running using the command systemctl space status -lsmb. So let us go over the server. So we are on the server right now and we should run the command systemctl status -lsmb. Systemctl -lsmb. So we see that the Samba service is indeed running. It's green here and active over here. Let us now create two users. Clear the screen. Let us now create two operating system users on the Samba server using the command user add user1 user add user2. And let us add these users to the Samba database. Remember, we are on the server right now. smb password -a user1. We have added the user1. Let's add the second user. So what we are going to do is that we are going to use this user1 and user2 from the client system to access the storage directory on the server Sujata. Okay, thank you. Hello, in this demo, we create a directory on the client system to mount the shared directory from the Samba server. We are on the client right now. Let us create the mount directory and the subdirectory remote. mkdir/mount. Create the subdirectory remote. This will be our mount point. The command to mount the remote shared directory onto the mount point /mount/remote is mount -t cifs -o username. We're going to use user1 followed by the IP address of the Samba server 192.168.1.12 and the directory that was shared on the Samba server storage and the mount point here. Now it's asking for the password for user1. Okay. The option "-t" is followed by the type of the file system that the kernel should mount on the client. In this case, it is CIFS, which stands for Common Internet File System. Let us run the df-k command to see if the mounting has been successful. df-k, and it looks like the mount has been successful. Yes, it is. Thank you. Hi, welcome to the new section, Sharing Folders Between Two Linux Boxes. In this section, you study the interaction between two Linux machines, where one acts as the Samba server and the other as its client. Creating users for the Samba database, a revisit. Mounting remote resources. Prep steps and installation of Samba on CentOS client. CentOS server. At this stage, we already have a functioning Samba server on the machine whose IP address is 192.168.1.10, which is a CentOS 7 machine. The CentOS client. You install the Samba software packages on the client whose IP address is 192.168.1.8. yum install CIFS -utils Samba, Samba -client, Samba -common. Note, they are the same packages that we installed earlier on the Samba server. We continue with the prep steps. Let us perform the ping test from the client CentOS system. Ping the CentOS Samba server. Ping 192.168.1.10. It is successful. We know that we can communicate from the server to the client and vice versa. Step 2. Check if the Samba service is running on the CentOS Samba server using the following command. So we go to the Samba server and run the command sudo systemctl status -l space smb. We are still in the prep steps. Step 3. Create user in the Samba database on the CentOS server. Sudo smb password -a user1. And we get a message here, failed to add an entry for user1. While trying to create a user, we get an error message. If you remember, in the earlier example, this worked. So the question is, why it failed now? The reason is that there must be a legitimate operating system user in the machine hosting the Samba server. Please read the line again. This is not a contradiction. The client will use this login to avail the services provided by the Samba protocol. So to avoid the error messages, we must create two operating systems users first and then use the two usernames to create Samba user accounts. Sudo user add user1, sudo user add user2. Add the users in the Samba database. Step 5. Let's create Samba users. Sudo smb password -a user1, sudo smb password -a user2. Two users have been successfully added to the Samba database. Checking the status of the server using the SMB client. Connecting to the Samba server from the client. We know that the IP address of the Samba server is 192.168.1.10. We should use the smb client command to check on the status of the shared directory on the server. This command shows the shared directory on the Samba server. You need to enter the credentials of the SMB users, in this case user1, user2, to see the shared directories. We are interested to see the shared directory storage that we created previously. We can see that the storage directory is clearly visible here. The output displays the storage directory. However, the point is not only to see the shared directory on the Samba server, but to mount it on the client as if it were a local directory. Now let us go over to the client server. To mount the shared directory of the remote system, create a directory which is called a mount point on the client. mkdir/mount/remote. This is the name of the mount directory. So let us go to the mount directory, cd mount remote. You can also use the existing mnt directory. The command to mount the remote shared directory onto the mount point /mount/remote is, you log in as root, mount -t cifs -o, username is equal to user1, 192.168.1.10, which is the IP address of the server, /storage, which is the directory that we have shared on the Samba server, space /mount/remote, which is the mount point on the client. Note, the option -t is followed by the type of file system that kernel should mount on the client. In this case, it is CIFS, which stands for Common Internet File System. It is a modern implementation of the SMB or Server Message Block Protocol stack. After you enter this command, it would ask for the password of user1. After you enter the password, check the df-k command to see if the mount has been successful. The output of df-k, and look at the last line. And the last line indeed shows that the mount has been successful. This is the 192.168.110, which is the IP address of the server, and this is the storage directory which we have shared, which is mounted on the client's directory called mount/remote. Unmounting. Create a file on mount/remote and check if the file is created. You can go back to the server and see if the file is created so that we can check out whether the permissions are working or not. To unmount, use the umount command on the client, umount space /mount/remote, and then check df-k. You should not see the last line /192.168.1.10/storage. Thank you. Hello, in this demo we check the status of the server, that is the Samba server, using the smb client command from the client CentOS machine. This command shows the shared directories on the Samba server. But before that, please remember that on the client also, you have to create the users user1 and user2. Remember the users that we created in the previous demo? On the server? Yes, you have to create the same users on the client as well. I have already created user1 and user2, so I would log in as user1 now. su user1, who am I? Now I will run the smb client command and see what directories Samba server has shared. smb client minus capital L 192.168.12. This is the IP address of the Samba server. Now it's asking for the password of user1. Okay, we see that the share name that we want, storage, is here. And remember the command we added by admin to enable storage for Windows clients. But we are going to use it on CentOS as well, that is on CentOS clients. Thank you. Welcome to the section Samba Troubleshooting. In this section you learn about troubleshooting from the Windows machine, downloading port QRA, stopping the firewall because of port QRA status, troubleshooting using Nmap, defining firewall rules on Linux, and denying access to a user using the Smb.conf configuration file. On the machine which runs the server side of Samba, TCP/UDP port numbers await for client request. They are specific port numbers and the client must know which port to knock to for availing services provided by the server daemons of Samba. These are either TCP, Transmission Control Protocol, or UDP, User Datagram Protocol. These port numbers are used as point of contact in the server running the daemons, which are background processes. A unique port number must be attached to the background process. This is for the specific computer. The client contacts the unique port of that system, after which the daemon takes over the request for further processing. Since such ports can be exploited by unscrupulous individuals, read hackers, we employ devices like a firewall. A firewall can be a software program installed on your system or a piece of hardware dedicated to the task at hand, and obviously more expensive and efficient. Samba service running on the server needs the following ports to be open, either to take care of the client request or communicate with each other. The ports are 445 TCP, 137, 138 and 139 UDP. In our scenario, the firewall has been enabled, leading to the Samba client not being able to access the storage directory on 192.168.1.10, which, as you know, is the CentOS machine running the Samba server. We will find ways on Windows and CentOS clients to conclusively prove that the firewall is indeed the issue. Troubleshooting from Windows. A reliable tool to troubleshoot for firewall issues on Windows is Port Query. Download this tool from Microsoft from the following link. The PPT slides are included in the lesson. We still continue with troubleshooting from Windows. The Port Query utility will unzip itself when you run the executable. Of course, before that you have to open a command prompt on the Windows machine and then run the following command. Port Query -n 192.168.1.10 space -p TCP space -e445, where -n is followed by the IP address of the target machine, which is the CentOS server running Samba in this case, -p for the protocol stack. As you know, 445 is a TCP port, -e the port Samba uses that we are querying, whether it's open or closed from the client end. You can see the result of this command, and you can see that, look at the last line, we have something called filtered. Filtered means that a firewall has closed the port in most of the cases. Let's run the same command after we shut down the firewall on the CentOS server 192.168.1.10. So we go over to the CentOS server and shut down the firewall using the command sudo systemctl stop firewall d. Now we go back to the Windows machine and run the port query command again. And we see that the status has changed from filtered to listening, which means that the port is open and waiting for client requests. We are still in troubleshooting for Windows. Unfortunately, here we hit a brick wall. The port query is unable to determine correctly the status of UDP ports in this case. However, the TCP port status determination, as per my experience, has been correct, and port query is a wonderful help to me. Welcome to the new topic, troubleshooting from Linux box. The firewall on the server has been turned on. We will use the nmap utility from the Linux client to check the status of the ports. You should log in as root to use nmap effectively, but first you may have to install nmap. Log in as root. The command is yum install nmap. We run the nmap command from the client in the following manner: nmap -p445 192.168.1.10. Check the word filtered, meaning that the port is closed. Here it is. And Samba will not be able to cater to requests from this client. This syntax checks for the single port. We are still in the troubleshooting from the Linux box. We now determine the status of the UDP ports used by the Samba daemon. And the command is nmap -su -p. We provide the range of the UDP ports used by the Samba server, 137 to 139, and the IP address of the machine that is hosting the Samba daemon, 192.168.1.10. To check for range of UDP ports from 137 to 139, let us now see the result. The -SU option is for scanning the port. So you can see that 137 is filtered, that's fine. 138 is also filtered, that's fine. 139 is also filtered. So the status is correct. Now, let us run the same command when the firewall is down. This is to create a yardstick of sorts. We see that the nmap unfortunately has not been able to get the status of the port 138 and 139 correctly. So let us check it. 137 is open, that's fine. 138 is open or filter, so nmap is confused here. 139 is closed. It should not be closed because the firewall is down. Now let us move over to a new topic, firewall rules for Samba. We need to add port 445 TCP and a range of UDP ports 137 to 139 in the firewall rules. After adding the rules, you will be able to connect to the Samba server seamlessly even when the firewall is up and running. Now it is time to add the firewall rules for Samba on the server that is running the Samba daemon. Log in as root, add the following rules. Firewall CMD permanent, add port 445/TCP, that's a success. Now it's time to add the UDP ports. Firewall CMD permanent, add port 137 to 139/UDP, that's a success as well. And then we just restart the firewall D service, firewall CMD reload. Now check if the ports are really added or not. Firewall CMD -permanent -list ports, and the output we get is 445/TCP 137 to 139 UDP. You should now be able to connect to your server with firewall D on and yet use the Samba services. Hello, we come to the last topic of the section, denying access to a host using Smb.conf file. Of course, you can achieve the similar result using a firewall rule, but it's simpler using the Samba configuration file smb.conf to deny a host, well, at least in this case. Now, in the initial configuration of smb.conf, we created a section called storage in the earlier sections. If you remember, storage comment added by admin to enable storage for Windows 10 users. Path was /storage and the area was writable. We still continue with the same topic. To deny access to the Windows machine or host whose IP address is 192.168.1.3, we use the keywords host deny equal to the IP address of the host we are trying to deny. So at the end of the storage section, we add this keyword host deny equal to 192.168.1.3. Now restart the Samba services, sudo systemctl restart smb, sudo systemctl restart nmb. Make sure you had used the testparm command to see if everything is okay. Now go over to Windows and try if you can access the storage drive. No, you can't. You get a permission related error, and that's what we wanted. Thank you so much. Welcome to Samba troubleshooting from the Linux platform. We are on the client and we are going to use the nmap command. But be careful, some people frown using nmap command. It can be easily misused by unscrupulous people. Let us log in as root to install the nmap command. Yum install nmap. Okay, the installation of nmap is over. Yeah, it's there. So to check the status of the TCP port 445 using nmap is nmap -p 445, that is the TCP port used by the Samba server, and then the IP address of the system that is hosting the Samba daemons, which is 192.168.1.12. Okay, so it is filtered, which means that the port is closed and Samba will not be able to cater to requests from this client. Let us check the range of UDP ports used by Samba. The range is 137 to 139. Nmap minus SU minus P, the range of UDP ports 137 to 139, and the IP address of the Samba server 192.168.1.12. Okay, so all these states are filtered, and filtered. Okay, let us go to the Samba server and shut down the firewall, and let's see how Nmap behaves. We are on the Samba server, that is the server whose IP address is 192.168.1.12, and we shall stop the server. Stop. Let us go back to the client and see what happens with Nmap. Okay, we are on the client. Let us run the commands again. Okay, this looks okay. Now it's open. The port is open because we have, of course, closed the firewall. Let us check the status of the UDP ports. Okay, 137 is showing us open, 138 it seems to be confused between open and filtered, and 139 is closed. Well, it seems that Nmap is partially reliable as compared to port query, or regarding the UDP ports actually, but there is enough information for you to use, and at least the statuses of the two ports seem to be quite okay, and the TCP port 445 the status is open, so it's fine. So you have to take this with a pinch of salt really. Thank you. Hello and welcome to Samba troubleshooting from Windows. We use a free utility from the Microsoft site called Port Query. It will unzip itself when you run the executable, and you should use it in the following manner. The purpose of this test is to see whether the port used by the Samba server, which is 445 and which is the TCP port, is closed or open on the CentOS server. Let us first check the content of the directory. We are on Windows, and the file that we are going to use, or the executable we are going to use, is portquery.exe. Clear the screen. Port query minus n, the IP address of the CentOS server 192.168.1.12, minus p, of course the port that is used by the Samba server is TCP, and the port number, which is 445. Let's see what happens. Okay, the status it shows is filtered, which means that access to the port 445 is closed by the firewall. Let us go over to the CentOS server and close the firewall and check what output is given by port query on Windows. So we are on the CentOS server. Let us stop the firewall. Stop. We don't get an error, so that's good. Let us go over to Windows again. Let us run the command again and see what happens. Oh, it has done very fast. So now the status has changed to listening. Taking down the firewall is not a solution, and the port should be always listening, which means that the port should be alive and listening to the client request. But as we know, taking down the firewall is not a solution because hackers will go and destroy your system or hack your system. So we need to add these rules in the firewall of the CentOS server. Hello, welcome to the demo firewall rules for the Samba server. The Samba server uses a couple of ports. The ports are contact points for the clients trying to avail the services provided by the Samba server. Hence, you need to understand which ports Samba uses. The Samba server uses 445 TCP and a range of UDP ports 137 to 139. So we need to add these ports to the firewall as rules so that we do not risk taking down the firewalls and compromising the security of our organization that can have dangerous implications. Log in as root to add the rules. Firewall CMD, it's an interface for the Firewall D daemon or the Firewall D software. Make it a permanent setting. Add the port. Let us add the 445, the TCP port. Success. It was already enabled while I was testing it. Let us add the UDP ports 137 to 139. That's done as well. Let us reload the Firewall D service. Firewall CMD reload. That's a success as well. Now to check if the ports are really added or not, Firewall CMD permanent list ports. So we have the rules here, 445, 137 to 139. This looks okay. You should now be able to protect your server with Firewall D and yet use the Samba services. Thank you.